Today's lesson is on dimensional analysis, which is a process that we use to help us convert between units. In this process, we will be using unit equalities, also known as conversion factors, in order to get our units to cancel out. I'm going to show you the general format for a one-step problem. Of course, we could do multi-step problems as well, but this will just be the general setup for a one-step problem. You want to always, when you read your problem, identify your known and your unknown. Your known is going to involve a number with its unit. So whatever unit they're giving you with, we'll call that the given. And make sure that you always put it with its units. Typically, in the problems that we're going to be completing, there will be nothing underneath your given. So I usually shade this in because students tend to want to put something in all the boxes. So there's really no number that you will need to put here for the problems we're going to be working on in first level chemistry. So notice I put like a T-chart here. Some students call it a T-chart, some call it train tracks. Whatever you want, however you want to refer to it. What comes after your given, this section here, this is where your conversion factor will go. And remember, your conversion factor is also known as your unit equality. I do want to remind you that conversion factors have unlimited significant figures, because there's no uncertainty in conversion factors. They are definitions. So they are considered to have unlimited significant figures. In other words, they will not be used to limit your sig figs in your answer. So where your conversion factor is concerned is you want to first focus on the units. So whatever the unit of your given is, that's going to be the unit that you want to put on the bottom diagonal here in the bottom of your conversion factor. So the unit that you want to cancel will go down bottom. Again, that's diagonal from your given. And then the unit that you want to keep will go on top. Now, this will be an equality, and so of course, once you get your units in place, you will have values or numbers that will go in beside of the units here. But you will always see, if you set the problem up correctly, the units will cancel diagonally. And that will leave you with whatever unit you wanted to keep. And of course, your answer will go here as well. So always box your answer in and then round it to proper sig figs. So let's look at 3 examples. We'll start off here with a really basic one. How many seconds are in 2.14 minutes? So our given is 2.14 minutes. That's what we're going to define as our given. And then you're going to put your T-chart. And I usually come over here and I'll go ahead and write down the unit that I'm trying to find. So we're trying to go to seconds. So you want to think to yourself, what do I know that is a relationship between minutes and seconds? Now, of course, we know that 60 seconds is equal to 1 minute. Oops, sorry. Okay. So we need minutes to cancel, so therefore we need to put it diagonal. We need to put it on bottom. And we need seconds on top in our conversion factor. Remember, in your conversion factor, the units you need to cancel will go on bottom, and the units you're trying to find will go on top. Now you're going to plug in the numbers into their correct location. So we say 60 seconds equals 1 minute. So we'll plug in 60 seconds equals 1 minute. This will allow minutes to divide out, and when you see your units canceling, you know that you've set it up correctly. So you're going to plug in 2.14 times 60. And your calculator is going to give you, of course, too many significant figures, 128.4. But we want to round this to proper sig figs. So look back at your given here. the given has 3 sig figs, and the conversion factor here has unlimited sig figs. So that means that 3 sig figs is our least sig figs. So when we multiply and divide, we round our answer to the least significant figures. So we need to round this to 3 sig figs, right? Here's where we're going to round the number. So you would record your answer as 128 seconds. All right, let's look at example 2. How many inches are in 250 centimeters? So we're going to start off with 250, put your decimal, and that's centimeters. And it wants us to convert this to inches. So inches will go over here. So now we need centimeters to cancel. So centimeters should go on bottom. And the unit you want to keep goes on top. So inches will go on top. Now I gave you this relationship here. I would not expect you to know this by heart at this point. So I will give you conversion factors that I would expect you not to have memorized already. So I would give you an inch is equal to 2.54 centimeters. So now plug that in. 1 inch is equal to 2.54 centimeters. Notice your centimeters unit cancels. So if it divides out, you've set it up correctly. So we're analyzing our units. So we're going to plug in 250, and then we need to divide. Since that's on bottom, we're going to divide by 2.54. Now let's look at our significant figures. We have 3 sig figs in our given because that decimal made that trailing zero count. 3 sig figs here and unlimited sig figs here, which means we need to round our answer to 3 significant figures. So plug that in and see what you get. Sorry, I don't know what happened there. So 98.4 will be your answer, rounded to 3 significant figures. All right, so let's look at a 2-step problem. How would you use dimensional analysis to convert when you're going to need 2 conversion factors? So we need to go from centimeters to feet. You're going to start it the same way. 86 centimeters is your given. And we're going to come over here and we're trying to convert to feet. So we'll put feet over on the far side. That's what we're trying to convert to. So we don't have one conversion factor that relates centimeters directly to feet. So we do know, though, that we can convert from centimeters to inches, and then we can convert from inches to feet. So we're going to use 2 conversion factors. That means we're going to need to set it up for 2 conversion spots here. So this will be where our first conversion factor goes. Here's where our second conversion factor will go. So we need centimeters to divide out first. So focus on that. Get your centimeters on bottom. And we know that 2.54 centimeters is equal to 1 inch. So we're going to put inches on top and then fill in your numbers to this equality. 1 inch is equal to 2.54 centimeters. This allows centimeters to cancel out. Now, if we stopped our problem right now, our answer would be in inches, but we want to go all the way to feet. So we need one more step. So now we need inches to cancel. So place inches on bottom and feet on top. We know that 12 inches equals 1 foot. This will allow inches to cancel, and it leaves feet as our final unit. So when the unit that you're wanting to find is the last unit in the top right-hand conversion box, then you know that you're ready to plug the numbers into your calculator. Now notice, this is treated like a big fraction bar. Okay, so everything on the top is considered your numerator. So we have 86 times 1 times 1. And everything on bottom is in the denominator. So we need to divide by 2.54 and we need to divide by 12. So I would plug this in my calculator. 86, I would say divided by 2.54, and then I would say divided by 12. Alternatively, you could say 86 divided by, and you could use your parentheses keys, 2.54, and you would want to say multiplication sign, 12, close parentheses, just to make sure it multiplies these two together.